Hello everyone. I am Ms. Shweta Patil from College of Engineering, Sangli, Department of Electronics Engineering. So today in the video engineering class, we will discuss about composite video signal. So what is basically a composite video signal? So here the composite video signal is nothing but it is divided into three parts. That is, first of all, it is having a camera signal, then flanking pulses, and then synchronizing pulses. So camera signal is nothing but it is corresponding to desired picture information or actual picture information which we observe on the TV screen. And blanking pulses are used to make the retrace invisible. Then the synchronizing pulses are used to synchronize the transmitter and receiver scan. So here basically we all know that in the video engineering, that is, screen is scanned horizontally and vertically simultaneously. So obviously there will be two types of synchronizing pulses. So first will be horizontal sync pulse, then vertical sync pulse. So their amplitudes are kept same, but their durations are kept different so as to identify them at the receiver side and for the proper operation. So basically, the composite video signal consists of three parts, that is camera signal, flanking pulses and synchronizing pulses. And the synchronizing pulses are divided into horizontal sync details and vertical sync details. So in this module, we will first of all go through the basic definitions of composite video signal. Then we will move towards the horizontal sync details, that is how these horizontal sync details are derived. Then vertical sync details, that is how the vertical sync details are classified like that. So first of all, this diagram shows you that is composite video signal for the three successive lines of scan. So here first of all we will go through some basic definitions here. So observe here, this is nothing but the peak white level. So peak white level is nothing but maximum brightness to be handled by the TV set, and it is generally set at 10 to 12.5% of maximum value. So if when you are changing the brightness through remote control, you are changing this value from 10% to 12%, 12.5%. So here peak white level defines the maximum brightness to be handled. Then obviously the black level. So black level for the composite video signal is set at 72% of maximum. So your picture information or active line period information will always lie between, that is 10 to 12.5% to 72%. Within this range only you will be having different shades of color. Then the blanking level. So blanking level is set at 75% of maximum value. Then above the blanking level, that is nothing but the darker than dark level. So darker than dark level is from 75 to 100%. Then the next is the DC level. So what is DC level? DC level is nothing but average value of a particular active line. Then pedestal height. So pedestal height is nothing but the difference between the pedestal level and the DC level. So that is called as the pedestal height. So we all know that horizontal scanning frequency in case of TV is nothing but the 15,625. So here one active line duration will be 64 microsecond. Out of that only 52 microsecond will be the active line period. That is for 625 line scanning system, the horizontal scanning frequency is 15,625 and vertical scanning frequency is 50 Hz. Like that. So accordingly these standards are different. Now next is, so these definitions we have already talked about. That is nothing but peak white level, black level, blanking level, pedestal, DC component, all these values. Now we will move towards the sync details. So we have seen that there are two types of sync details. That is nothing but horizontal sync details and vertical sync details. So horizontal sync details are derived as first of all, these horizontal sync details can be described by these three diagrams. So first observe the picture space or the raster. Second is nothing but the composite video signal of the one active line period, and third is nothing but the horizontal deflection coil current. So here we know that for 625 line scanning system, the horizontal scanning line frequency is 15,625. So here the total duration will be 64 microsecond, but out of that only picture information is available for 52 microsecond, and rest 12 microsecond period is nothing but the retrace period. So this 12 microsecond retrace period is divided into three parts. So first will be the front porch, second is back horizontal sync pulse, and third is back porch. So this total is called as the horizontal blanking period. Now observe here the current flowing through horizontal deflection coil. that is linear rise of current in horizontal deflection coil will move the beam from left to right end of the raster so as to scan the that is information available on particular line. Then this 12 microsecond retrace period is actually used for beam to go from right to left end of the corner so that it can scan the next line. Now we will discuss about this part, that is nothing but horizontal sync details. So first is front porch. So if you see here, front porch is of duration 1.5 microsecond. So this front porch, that is the significance of this front porch is nothing but for settling of the level. That is nothing but settling of the level from whatever level that is existing at the end of the active line period. So all the time when the next scanning line appears, it should start from the that is front porch, or it should start from the flanking level. So this is kept at one point. The duration of it is very short, that is nothing but 1.5 microsecond, and is used for settling of a video. So here next is nothing but horizontal sync pulse, which is of duration 4.7 microsecond. So this is nothing but the retrace, or actually the retrace happens during this period. Or here the beam is going from right to left end of the corner so as to scan the next line, like that. So here this duration doesn't contain any information. So here if you observe, the amplitude is kept 100%, or you can see the level is darker than dark. So here another uh, reason for keeping this amplitude as 100% is nothing but that is to make the retrace totally blank. Because if you keep this in between 75 to 100%, then you will be having that is somewhat that is spots that can be observed by human eye within this retrace period. So this retrace is totally blank by keeping it the amplitude equal to 100%. So if you observe the horizontal deflection coil current, that is here actually your retrace begins. That is the beam when the current linear decrease in the horizontal coil current is responsible for bringing the beam from right to left end of the corner so as to scan the next line. Then the third part is nothing but the back porch. So back porch is nothing but its duration is kept that is higher than the rest of the two, and the duration is 5.8 microsecond. So actually the significance of keeping the back porch is nothing but it is the nothing but the time required for the horizontal sweep oscillator so as to reverse the direction of current so as to scan the next scanning line. So here the duration kept is more than this rest of the two. And another significance of back porch is nothing but here the color burst signal is added during this back porch. So here the color burst signal is responsible for getting the colors at the receiver side. So if this color burst signal within this back porch is absent, then you will be having just monochrome reception. So here the significance of back porch is nothing but that is to reverse the direction of current, and second will be the adding the color burst signal, like this. So all of you are getting this detail, that is the 64 microsecond of the total time period is divided into 52 microsecond of active line period, that is nothing but the actual picture information, and 12 microsecond of retrace period. And this 12 microsecond period is again divided into these three parts, that is front porch, horizontal sync pulse, and back porch. Here, this horizontal sync pulse is actually responsible to trigger the horizontal sweep oscillator so that it can reverse the direction of current so as to bring the beam from right to left end of the corner. So all of you are getting these details of horizontal synchronization. Then we will move towards the vertical sync details. So here the vertical sync pulses are added at the end of each field. So during 625 line scanning system in India, here in case of interlace scanning, the total number of scanning lines are divided into two fields. So for 625 line scanning system, it is divided into 312.5 and 312.5. So here vertical sync pulses are added at the end of first first field, that is nothing but at the end of 312.5, and second will be at the end of this 625th one, and its duration is equal to 2.58, means 2.5 into 64 microseconds, so that will be 160 microseconds. So these are just the locations of your vertical sync details. So what is basically the significance of adding these vertical sync details? So similar to horizontal sync pulse is responsible to reverse the direction of current of through the horizontal deflection point so as to bring the beam from right to left end of the corner. Similarly, vertical sync pulse signifies that here it is also provided so as to reverse the direction of the current through vertical deflection curve, because vertical movement of the beam is from top to bottom and bottom to top. So at this point here, when this pulse appears, then vertical oscillator will reverse the direction of current, so that now beam is moving from bottom to top of the raster so as to scan the second field. What happens at second field? That is here, where at the end of 625th line, when this point appears, the beam is again moving from bottom to top so as to scan the next frame. So here vertical impulses, that is ensures that proper triggering of vertical oscillator at the end of both the fields. That is so as to synchronize the vertical scanning. Okay. Now here observe these two waveforms. So from this we are getting two observations. That is, during these vertical sync pulses you are having horizontal sync pulses absent. So here the horizontal synchronization will be lost for this 160 microsecond and for this 160 microsecond. But this should not happen. So to avoid this, the solution is serration or notching. And second observation from this graph is nothing but half line discrepancy problem. That is, here the vertical sync pulse appears after the half line period, that is at the end of 312.50. But in case of, that is, second vertical sync pulse appears after full line period. So here this half line discrepancy problem will create that is triggering of oscillator at different times at the end of two fields. So this is again problematic. So to avoid this, the solution is pre and post equalizing pulses. So about notching and or serrations and post and pre equalizing pulses we will discuss in our next class. Thank you.